Good day, guys. How are you doing today? Today we continue our lesson series from where we stopped. Today we are looking at derived type in C, solving real-world problems with structures, array, and pointer. Now let's dig in. Now we look at what are derived types. In C, we have some primitive types, which are the int, char, float, etc. But they allow us to organize and manage related data more efficiently. That is the derived types. Derived types include arrays, pointer, structure. Though we talk about structure in some of the video, but not what detailed. I'm going to explain in detail here in this video series. We also look at array is a collection of similar elements together. Also have a pointer, a variable that stores the memory of address of another variable. That structure is also called structs. It's a collection of variables, possibly of different types. This one allows us to have a group of different types together. We also have union, similar to structure, but remember share the same memory location. But also have enum. Enum enables us to define some series of constants. For example, you can have a day of the week. You can have the day, it can be constant, but by default, you don't assign value to it. It's going to take the default zero, start from zero. You can also assign value to them based on which one you want. Now, let's look at some kind of real problem on where this derived type can be used. Imagine we need to build a simple system to manage student information. Just as you are, as a student, we have your information. You don't want to log into your portal. As a single user, you will have your matric registration number. You will have your name, the first name, surname, and other names you are using. Then you have maybe the kind of your age. So those can be structured to one single person of which you and any other necessary information required by the system. For each student, we need to store the student ID and also the name of the student, the grade, the average grade as well. We also need to be able to create a new student record, find students by ID, calculate average grades, find student details. And seeing this structure enables us to carry out these informations. A structure for student data. A struct or structure is ID for grouping related data of different types. We can have your string in C. You can have your character of strings, character of your names. You take the form of characters. Your age you take of unsigned because you cannot have a negative age. And you can also have your ID can be in form of string as well or integer, depending on how the format of your ID is, your student ID looks like. For example, let's create this is the structure of what? This is the structure of this is the way struct looks like. We give it what? A type def struct, then you put the name at the bottom here. So this is the name. Anytime I want to call this struct, this just it's not a vague word. Struct enable us to have multiple type grouped to one places, unlike the one we do use before, like int, storing only one value at a time. Char can take only one value at a time per entity. Also float, but this one can take several types together. This student type now encapsulates all necessary information for one student. Now, for example, let's see it here. You can see we have this. This is the name of the student here. I'm going to demonstrate for us as well of different ways you can have your struct. The one you preferred, you can choose that one. So we have student X1. You have student X1. You can be anything. You can be STD. The point depending on the kind of abbreviation. You can also make it a small letter student of what you need. So this is the instant variable that we have here. Then we can now use that variable to what? With dot operator to what? The ID. We call the ID. We give the value there. So we'll be able to reference all the other variables that we declare inside the struct. just with this one, the variable declaration of a student here. Then we can also what? We cannot assign string. For example, we use Alice Smith here. You can just put your name. You can just assign this this variable just the way we assign it here. Because we're going to be having some kind of error of mutability of the character strings. So we're going to see it also in demonstrations. By the time we also come into demonstration, we also see you can also assign this value now. Now we can have it for different series of students. So we have the same unique model for any student to supply their unique informations. Now, look at pointer and memory allocation. So I'll still leave a memory allocation for us in the future. We have memory allocation future in the next video, in some videos to come. So we don't know how many students, in case we don't know how many students we have before at hand, then we can use also what can allocate several memory, additional memory to array using a malloc calloc. A malloc means memory allocation, and memory, the LLM means allocation. Calloc means categorical allocation to create record at runtime. A pointer to a student structure. Let's create a pointer to a student structure now. You can go create a what? After creating the structure the way we created it on top, you can also what? Create in form of pointer. We have seen in our previous videos, we can create pointer using the asterisk. The asterisk can be in the middle, can be beside these. This student, just like for example, your int is float or double. Just treat it that way. But it's a what is the combination of multiple types together. You should remember that. Then we now create what you want to create additional memory to array, memory allocation at runtime. This one, the other one we did before is at compile time. You know, we check it, but at runtime, you're able to what allocate more memory for us. Then, for example, how does this thing work here? So I'm going to explain in more details for us in the next video, as I said. But I'm just explain briefly here. We create a new student here. This is the variable here. We now what? This does not return something, but we have to cast it. Casting means converting to one type. So we have to, it return, this is the student here. You get the type of the student here. The size of enables to know the size, which is what 1 byte. But mind you, since it's no longer 1 byte, it will add all the type here together in byte. We know int to be 4 bytes, and we know car here to be 1 byte. And now but here we now have 50 here. 4 plus 50 will be 54. Then we have float, right? Float. Then we also have what? Float of average. Also our float is also 8 bytes or 4 bytes. 4 bytes. 4 bytes. So to sum them together to be the total size of this. Then you can now cast it to become of type new student struct. To be it will take the type of this. So we're able to check. We now check here. Is the new student type equal to null? Is it null after casting, after creating a new? If it is not, we can easily handle the error here. Else we can continue with the program. When using a pointer to a structure, we use the arrow operator like this, that your dash and the greater than sign to what? To access its member. If you're going to use dot operator, you're going to receive an error. I'm going to demonstrate them together as well. Then we have member. Remember, to free dynamic memory allocation. Yes, anytime you are creating a pointer, you are creating a what? New memory here. You need to put this one inside the what? Inside the free method to avoid what we call memory leak. So sometimes again you are accessing what is already turned to null. The good part is for you also to include what null. Accessing can also, when something also called dangling pointers as well, as when it's no longer available anymore, you are still also accessing it. Now let's look at function returning a pointer. We can see some function. We can the way we create our functions. Now, before we do put int here, like float, or you can easily put even normal student without asterisk. That means it's not a function pointer. But here now it's a function pointer. Then let's create a function to initialize a new student record dynamically. This will enable us to create new student record dynamically. Then this student will return a pointer to the newly created student structure. Then we have, for example, we create the student this is the function name, this is the type of the student. Then we pass the parameter inside. This is the parameter inside. We open the close braces, or we close it, we open braces here, and we end it down here. Then we check is s equal to null. Let's check z at compile time. We have a new size for memory. If not, that means p error, memory allocation fail, return null. So nothing will be done. Just the program will stop there. But here now, you can see the arrow that I told you earlier. This arrow is being done. You don't use dot operator since we are using pointer here. We are using pointer, also memory allocation. So we cannot use a dot operator. So we use the forward and the dash, some and greater than some. So, but in your VS Code, you can easily press it. But then you press and it shows you down. Just click on tab. It will change automatically to this sign. Or you can also do it yourself. Then you cannot copy the string copy. For you to use this string copy and also this malloc label, there's something you need to include in the header files, which are the header file. Let me see. The std library, and the string header. So it needs to be included in your program before it can work. Then we can see string copy, you can assign grade 0, grade 0, grade 1. Imagine in our struct here, it's taking 3 elements. That means we are taking 3, we are creating 3, where is the struct? Okay, this is it here. So we are expecting 3. It's an array of 3 elements. So that is why we are assigning the grade 0 to be G1, grade 1, grade 2, and grade 3. It should be enough. Can you see? We have it here. Maybe we got 75.2 or so. You can see, or 0.5. You can see. That's why it's make a floating point. So that is how it's done. Then using the create new student functions. And you can see here now, I have a sample, for example here. The stdio enable us for the word, the standard input output. The std library for malloc, free, and calloc program memory allocations. The string h enable us for string copy, string manipulation, smoothing string for one, copying string from one variable to the other. So you can easily create what you cannot call that functions. You call what with the student ID of 101, with the name Alice Smith, with the first grade of 85.5, what 90.0, 78.8. You can also what if the student, that means this student 1 is equal to null. Print student ID this I will this. Then you can also get this. Don't forget to what to free. Don't forget to free this as well. If this one is not equal to null, sorry. If not equal to null, you can easily calculate it and print it. You can see I put here. Don't forget to free your base. And I can also set it to what to null. Then you can what you can easily create another one again called Favor Johnson. You can what give another score. It's 2.0, 95.0. Then let's create students. Let's create returning a structure only by value now, not just using pointer, not a function pointer now. Then just create the same way. Create student, update student grade, student X. We're passing even a struct inside as a parameter to the functions. Float new grade 1, grade 2, and grade 3. You can easily assign it here. You can assign the s.grade. The s is the object we are passing. That is the struct. The struct object we are passing in. Then return a copy of the modified student struct. This will return, because why are we returning s here? Because we also have student here. If it is integer here, we cannot return x because s is of type of student here. The type of student here. So s is the type of this. So this is what matters. What to return here is what is we put here. It is float, that means we are going to return float. But since we are returning object of struct, we are going to what? Return an object here. So then we are using the update student grade functions. You can also update this. You can also upgrade. You can follow the examples. Then you can you do the same thing for the way it should be done. Then using the upgrade, okay, sorry, my slide. Function returning an array. You can also make a function to return array. Function is in C, cannot directly return array, unlike Java and C++. You cannot just do that. You can just return like returning array in C++ or Java. So then, but you can find a way of doing that by using an array or using a pointer. Function is in C cannot directly return entire arrays by value. However, they can return a pointer to the first element of an array. Yes, the point to the what? It's pointing to the what? The first element of an array. This often involves dynamic allocation within the functions. Now we create a what? A pointer function here, calling generate random grades. Then you taking a parameter and you put the what number of subjects, float grades this. We can also create number of subject time multiplied by the size of this number of objects. If the number of subjects you want to do just 5 subjects that you register, can just multiply by the size of this, so you have enough space at runtime. You check if there's error. If there's no error, then you calculate. You use our for loop statement to initialize. Then we check if I is less than the number of subjects. Then these are integer. Then we now get the first index. Then we assign the value, we get the value, we find the random, you find the modulus of it, divide by 100 in floating point. You know that having f here is mean what? It's a float. It's a float. So we have to also return float here as well. So make sure that it's a float, then we return float as well. Then, so you can do the same thing here. You can look at it here, so you can go through it and go through it yourself. In conclusion, derived types, arrays, pointer, structures are fundamental to writing robust and efficiency programs. If you know arrays, pointers, and structure, in fact, your C knowledge is already grounded. So, and union and enum, so those of just BP a child's play. They allow us to model complex real-world entities and relationships. Understanding how functions interact with derived types, especially return pointers versus values, is critical for correct memory management, preventing common errors like dangling pointers, and writing modular and reusable code. In practicing this is one of the key concepts in learning your C programming language. So, but if you don't practice it, if you just write or just forget, but we soon forget them. Now let's try to jump into, let's open our Visual Studio Code. Let me see the font size. Okay, just put it in 22. Okay. Okay, let me open recent. Sorry, so let me open. So, good. I have some of them here, but let's demonstrate together one after the other. So let me create a folder. Just call it a folder here. Just sample 3, and let me just I'll just rename it to lesson 9, P9, then P9, then we have just app.py or sorry .c, then we have include stdio.h. Don't forget, for example, if I want to include let me call the malloc, for example, if I want to say, okay, x of this, answer x equals what? Malloc. And you see, it's not even giving me the IntelliSense. But if I try and include the std library, std-lib, then I should be able to have it. Malloc. Can you see? Yes, I can easily have that now. Then you can easily get our struct in this way. You can just struct and give the name of our student. For example, maybe int id. For that, we make it of what? Unsigned. Assign int id. Then can name. What the size we are giving? We give it 100, for example. Then we have maybe for example, you got just get grade, float grade. So I want us to see some things here. Yeah, let me put something here. You have to put semicolon here. Now, this and that one method, but the one we saw in the slide is struct type definition, def student. Let's just name that what? Struct as well. But let's give it a name. We have to give it a name, student 1 here. Just name that student 1. The same thing, but I will tell you the difference soon. Then you can also have the same thing. Just copy the same because of time. And paste it here. Then we have the same thing here. Now, what's now the difference here? If I want to call this, anytime I'm using this method and approach, student, that means I have to always put struct in front of it. If I say, okay, student of what? std1, you see that and the first struct is undefined, right? So I have to put what? Struct in front of it. And you see, it disappears. So, but I want to try and use, anytime you are using that, so you have to be putting struct in front of it. So I don't want to do that. When you're even using it with the function as well, you have to put it in struct with a function as well. For example, we say, okay, student, and you call the name of maybe function sample student, maybe it's int std student id. Then we have it here. You have issue here. It's undefined, but you have to put struct in front of it. So then we find here, just the same way we set struct x. Then you can also see return x. Sorry, struct student. Then we have x dot id equals what? std id. Then we can easily return our student, our s now. So that will be fine. But to avoid that, we can easily use the other one, which is what? Student 1, std1. Then this should not give us error. We don't need to put struct in front of it. And that is fine. Now we can easily calculate all the total size of this. Then to calculate the total size of it, we should be able to get maybe printf. For example, printf d. Then we have n size empty struct. So we want to have empty struct without anything. So let's just get the value. Then let the size of structs. Size of Struct, yes. Coming. Struct, maybe struct new student. Student, what? Students. Student X. Yes, great. So, students, yes, new student. Then we calculate the size. Same thing for size 1, size 2, empty. This one is not empty struct. Let's get it with maybe this one is student. Yeah, this one is student. This one is not even empty struct now. Okay. Let me create an empty struct here. Struct empty. Empty. Then just change this one to empty. Then you should have, yes. Now let's compile this one. CD P9 G plus plus. Actually, you won't have it here. Let me just compile here. I'm having an issue here. STD1, what is it saying? Not previously declare of STD1 with type structs. STD1. I'm coming. I'm just updating that message very quick. G plus plus hyphen O. I just name it as app.c. Then okay, get inside conflicting declaration. Student 1, STD1, student STD1 as well. Okay, I'm having STD1. Okay, they are both same thing. Let me change this one to STD1 and this one to be ordinary STD. That means it should be clear now. Good. Then app. Can you see the total? This I want to show you. Empty structs take only 1 byte. But here, that's 8 bits. But here we have 108. Summing all these things together will be 108. This one is 4 bytes. That is 4. Float is 4 bytes. Making what? 108. Understand? 108 for us. Then let's go ahead. You can also return a functions. To do that, you have seen a sample of it. You can also demonstrate the code we've written before on to prevent this video being long. So the next video will be for exercises. So I want to solve some exercises and let's see how we can also achieve that. But before I go, you can also do something and create a variable with this student ID. For example, we give it a name. Let me just prevent this video. You can demonstrate the example I have that I've shown you the slide. If you have issue with it, please let me know. Have a nice day. Bye-bye.